Okay, welcome to Algebra 1, Semester 2, Unit 8B, Section 9, 5, 6, and 7. We've got quite a few sections, but just a few problems in each one. Just some new things that I want to make sure and show you. Okay, this one is factoring the trinomials. If you remember right, in the previous section, we've been factoring... let's turn back to page 3 and just kind of review. We were factoring 4 terms, and you did it 2 by 2, and then you would take what was common amongst them and bring them out. So now with 3 terms, you really need to convert them to 4 terms in most cases in order to factor them, unless there's a special pattern that you're following, which I'll show you a few tricks on that. But really, the only way to do 3 terms is to bring it out and convert it to 4. So we use that X game that we've been playing in class. If you haven't been there, the trick is you take the top number, that's what you add to get, and you take the first and the last number, you multiply that, so here it would be 12 because that's a 1. So what 2 numbers multiply to be positive 12 add to be 7? Well, because it's a positive 12, we know that their signs will be the same. Because it's a positive 7, we know that they'll be positive. Now we think of all the factors of 12. We have 1 and 12, those would add to be 13. 2 and 6 add to be 8. 3 and 4 add to be 7, so we know that it's 3 and it's 4. There's only one option every time. So there's only one answer to that. Bring the x down from the 7. What you're doing here is you're converting from the 3 term to 4 term. Some students that I have will circle these 4 terms to remember what they're writing. When they do, oftentimes they'll say that those are the grandpa glasses because they look like grandpa's glasses, the old wire glasses laying on the desk. So we have x squared plus 3x plus 4x plus 12. Now you go back to the same skill that you practiced on page 3, which is 4-term factoring. Take out what's common. We have x. That would leave an x plus 3. Now we want that term to occur again because we'll end up factoring it out. So we ask ourselves what times x would be 4x? It would be a positive 4. 4 times 3 is 12, so it all works. Now we factor out that x plus 3. And then in the other set of parentheses, we put what's left. Okay. I want to skip down to one of these now because I don't want you to get in a bad habit with that first term being 1. So I want to show you how this one looks. We have the x game again. We want to convert it to 4 terms. We need to take the 2 times the 3 to get our bottom number, which would be 6. It's a positive 6, so we know the signs have to be the same, but this time we have a negative up there, so we know that they would be both negative. Now the factors of 6 that would add up to be 5 would be 2 and 3. Doesn't matter the order that I write these in. You'll get the same answer either way. Bring the x down, circle our terms, and now write your 4-term polynomial. 3x squared minus 2x minus 3x plus 6. Okay? Now we factor out of the first 2 terms. What's common in both those? Well, there isn't a number that will go into both 2 and 3, other than 1, and it doesn't break it down at all for us. But there is a variable, so we have x that will go into both. The lowest exponent on x in this is 1, so it's x to the first. X times 3x will give us 3x squared. X times negative 2 will give us negative 2x. Now we repeat this right over here. And I'm looking at it and thinking, oh man, I made a mistake. But here's what I did is I made a typo here. I put the 6 from down here in my equation, and it has no part of the equation. The fourth circle there is a plus 2. That's what I should have had. I apologize for that. Okay, now we ask ourselves, what times 3x gives us a negative 3x? That would be a negative 1. Double check that it works here. Negative 1 times negative 2 is positive 2. So now we factor out the 3x minus 2. And the two factors we have left are x minus 1. Cool thing is, if you take these binomials and multiply them, you'll come back to getting your trinomial that you were given originally. Remember, multiplying and factoring are reverse of each other. So you can always check by doing that. Let's go back up here. Now, I don't know if you noticed, but when we had a 1 in the front, the factors that you found here ended up being right here. That is a shortcut. So you could just take that shortcut. As soon as you find your factors, you say, well, that's 1 times negative 21. My factors would have to be a negative and a positive this time, so I'm looking at their differences. What two factors have a difference of 4? My factors of 21 would be 21 and 1, that would be a difference of 20. 7 and 3, that's a difference of 4. The larger one, or I shouldn't say the larger, the one that's farther from 0, will have the same sign as that middle number. 7 is farther from 0, so we have negative 3y, positive 7y. Now we can go ahead and do all these steps, or we could just skip to our answer. Since there is a 1 in front, we know that our answer will be y, because it's the first term, and a minus 3, and a plus 7. Okay? Now, when the first term is not a 1, you cannot use that shortcut. See, for example, here, we had a 3 as our first number. We didn't know how this would split up. We had a negative 2x and a negative 3x as our factors. They did not show up in the answer. Okay, so we have to use the x game when the first number, when the leading coefficient is not a 1. So here we do our x game. 1 times 9 is 9. What two factors multiply to be positive 9, add to be positive 6? That would be plus 3 and plus 3. We bring down our variable from the middle term, circle our terms, and we rewrite with 4 terms. 9y squared plus 3y plus 3y plus 1. Underline the first two. 3 will go into both those, as will y. 3y plus 1. We look over here, we write the same thing, and we see that we don't need to multiply it by anything except for 1. So now we factor out the 3y plus 1. And what we have left happens to be 3y plus 1. So those are our two factors. Please, on a situation like that, show me that you understand that that is a perfect square, that is a binomial square. So give me the final answer like that. Okay, back up to 1 with the 1. Okay, we need two numbers that multiply to be 8, positive 8, and add to be a negative 9. So I think of all my factors of 8, they're going to have the same sign, but because that's negative, I know that they're both going to be negative. So all my factors of 8, I have 8 and 1, 2 and 4, and that's basically it, unless I just turn them around in order, which won't matter. Now, which ones add to be 9? It would be the 8 and 1, so I just plug those in. They could go in either spot. Okay. Next one, again, it doesn't have a 1 here in the front, so I can't do the shortcut. I have to do the x game. This is a 1 here. Negative 21 times 2 is negative 42. And so I'm looking for factors of 42. They'll have opposite signs because it's a negative 42. So I'm looking for factors that subtract b1. I could do 1 and 42, but that would be 41. I could do 2 and 21, but that would only be 19. I could do 3 and 14, but that would only be 11. I can't do 4, I can't do 5. 6 will go in there 7 times, and there we have it. Now the one that's farthest from 0, the 7, will have the same sign as this. Bring down our variable, and here's the order that we're going in, right up around like that. So we have 2m squared plus 7m minus 6m minus 21. And again, it doesn't matter which order you put these two in, you'll get the right answer either way. So 2m squared minus 7m, we can pull out an m. We can't pull out any number. And we write that binomial again. And we ask ourselves, 2m times what equals negative 6m? Be a negative 3. Negative 3 times 7 is negative 21. So now we have 2m plus 7 that we factored out. And it